There is a rod whose mass is 2 kg and length is 30 centimeter. Let's consider this is the rod whose ends are A and B and mass is 2 kg and length is 30 centimeter, which means 0.3 meters. Now, one impulse is given at the end of the rod, this B end of the rod. That impulse, let's write it as J equal to 0.2 Newton second. So due to this impulse, what happens? The rod is going to rotate about its center of mass. An axis is passing through this point into the page. So it is going to rotate and it is going to make an angle perpendicular or right angle like this. So this will become A, this will become B. So like this, it is going to rotate. And for this, how much time it is going to take? That's what we need to find to answer this question. So let's write the impulse. Impulse, we can write it by multiplying the force and time. So the total impulse will be F integration of F dt. Of course, sometimes we will simply write F into t, but here we can find it using integration also. F into dt. And this is given 0.2 Newton second. Okay. Next, this is like a linear impulse. We can write in the same way angular impulse. Let me write it as m. The same way we can write, instead of force, we can use torque, tau into dt. Now, in this case, if you want to find the torque, then this will become force into L by 2. You see the overall length of the rod is L and the axis of rotation, distance between axis of rotation and the point in which we apply the force or the impulse is going to be L by 2 distance. So that's why F into L by 2 dt. Now I can take this L by 2 outside. This will become F dt, which is nothing but the impulse. So I can write L by 2 times J. So the angular impulse becomes L by 2 times linear impulse. L is 0.3 by 2 and this is 0.2. So we will get 0.03. This is the angular impulse. So let me write here m equal to 0.03. Now we need to find the theta. Sorry, we need to find the time period. So for that we need some information about the angular velocity. So I'm going to write this angular impulse using moment of inertia and angular velocity. So the other way to write impulse, say for linear impulse, is change in momentum. Similarly, angular impulse can be written as change in angular momentum. Okay. So here L doesn't mean length, supposed to be angular momentum. Oh, okay, I can change this here. Let me put it small L. Yeah. So this one also. So here the angular momentum, I can write it as I times omega. Since we want change in angular momentum, here the moment of inertia I is not going to change, only the angular velocity will change. So omega f minus omega 0. Omega 0 is 0. Omega f is non-zero, so it will become I into omega f, angular momentum. So I want this omega f only. So this omega f, final angular velocity, can be written as angular impulse times moment of inertia. Here, for this rod and about this axis of rotation, the moment of inertia is going to be ml squared by 12. So this is m, angular impulse. This is m L squared by 12. Fine. M is 0.03. This mass is 2 kg. Length is 0.3 squared. and here we'll get 12. Okay, so this will become 6. Then if we simplify, it's going to become 2 radian per second. Okay, so we found the angular velocity. Now we want time period. Somehow we know the angle also, the angular displacement also, that is 90 degree, because initially it is like this, then it turned out to be right angle, which means 90 degree, or I can write it as pi by 2 radians. Now this omega angular velocity, we can write it as angular displacement by time taken. Here we want time taken, which is angular displacement by angular velocity. So angular displacement 90 degree or pi by 2. This omega f is 2. So we'll get pi by 4 seconds. So the time period for the rod to rotate 90 degree or to make an angle, right angle, it takes pi by 4 seconds. If we compare this with the question, the x value, we will get it as 4. That's all. So try to understand the process in which we find the time period. Initially, I started with the linear impulse. Then I moved to angular impulse that I try to write in terms of linear impulse. Then I try to write in terms of angular velocity. Using that angular velocity and angular displacement, I figure out the time period or the time taken.